Hello everybody, a very warm welcome to all the viewers of wisdomjobs.com. In this video, I am going to discuss an objective question which might be expected in one of the competitive examinations like CHSL, CGL or NTPC RRB or other any competitive examinations. So please do subscribe to our channel wisdomjobs.com because we are going to do many objective questions which are probable in the competitive examinations which are forthcoming in the next month and the summer season. So please express your queries or doubts at the bottom of the video in the comment box provided, so that whenever we find time we get back to you and answer your queries. The question for this video is the four quantum numbers of valence electrons of potassium are. The given options are 4, 0, 1 half, 4, 1, 0 half, next 4, 0, 0 half and 4, 1, 1 half. So let me read it in the Hindi version. So in the Hindi version, पोटेशियम की वैलेंस इलेक्ट्रॉनों की 4 क्वांटम संख्या होगा डैश. Okay, now let me analyze the electronic configuration of potassium. Now before going to electronic configuration, what are the four configurations, what are the four quantum numbers we have? One is principal quantum number, next is azimuthal quantum number, next is magnetic quantum number, and lastly we have got the spin quantum number. Now n is the principal quantum number, okay, and what is L? L is the azimuthal quantum number, okay. Now it takes values from 0 to n minus 1, where n is the principal quantum number, okay. Next, and after that L and M. M is the magnetic quantum number and it takes values from minus L to plus L, okay. And lastly spin quantum number is having a values of either plus half or minus half. Now let me write the electronic configuration of potassium. What is the value of Z, the atomic number of potassium? It is 19. So if I write the electronic configuration, it is 1s2, 2s2, 2p6, 3s2, 3p6 and lastly 4s1, okay. So how many electrons are there? 2 plus 2 plus 6, 10, 12, 18 and 1, 19. So it is the electronic configuration of K19, okay. Now if you observe the valence electrons, okay, so valence electron is this one. This is your valence electron. So in the valence electron, what is the principal quantum number? The principal quantum number is 4, okay, n is 4. And for S subshell, since the valence electron is in the S subshell, as for S subshell, L is 0. L is 0. Okay, and if you take M, the magnetic quantum number, it varies from minus L to plus L. So for L equal to 0, it varies from minus 0 to plus 0. That means it takes only one value, that is M equal to 0. Okay, M equals to 0. So L is 0, M is also 0. Next, which is the fourth quantum number we have? Spin quantum number. Spin quantum number is either plus half of or minus half. Generally, the first electron, so if you observe how many electrons are there in the valence shell, only one electron, right? So for the first electron we take a plus sign, plus half, and for the second electron in the valence shell we take a minus half of the spin quantum number. So based on that, so the spin quantum number is half, okay. So now for this valence electron in 4s1 subshell, it is what? N value is 4, L value is 0, next M value is also 0 and spin is half, okay. So now let me check which is the correct option for our answer. So 4, 0, 1, 2, 1 by 2, so this is wrong, okay. So this is not the correct option. Next, let us see B, 4, 1, so 1 is wrong, so B is correct, not the correct option. So if you observe 4, 0, 0 half and 4, 0, 0 half, so our option C is the perfect match, and obviously D also is the wrong answer. So if you know what is the electronic configuration of potassium and if you know the limits of L and M, then easily you can identify this particular sequence of quantum numbers. Now for example, if instead of 4s1, if I am talking about, let me say, the valency electron is in 4p subshell. So for 4p, n is equals to 0, sorry, n is equals to 4, L for p subshell is how much? 1. Okay, and once again it depends on whether it is when the valency electron is moving into either 4px or 4py or 4pz. So for 4px, m is -1. So for 4px, m is -1. Okay, and for 4py, m equals to 0, and for 4pz, m is equals to 1. So in this way, for p we can have 3 values of, for p subshell we have 3 values of m. Similarly for d we can have 5 values of small m. So in that way we can easily identify the quantum number set for each and every valence electron of a particular element. Okay. Hope you enjoyed this video. Please do subscribe to our channel wisdomjobs.com and share and like these videos to your friends so that they also will be benefited by these videos and they also can get good scores in the competitive examinations. So if you have got any queries, please express them in the comment box provided, and as and when we find time we are going to answer your queries. Thank you for watching. Have a nice time.